So we're moving on with our discussion of units, and I'm going to go look back again at this tool called dimensional analysis. Now this was in the notes for the metric system. If you weren't someone who liked the slidey chart, I was suggesting dimensional analysis. We're going to give it another go, and you may actually go back and find that you like it better than the slidey chart once you understand it a little bit further. So we are going to talk about converting from one unit to another unit, and this is something that is huge in the second half of Chem 50. It's a problem-solving strategy that's really powerful when it comes to chemistry and the math behind chemistry. So what we're going to do is convert from one unit to another and use an equivalence statement. So an equivalent statement that we may have used was that 1 meter had 100 centimeters in it. And basically what we can do with this is arrange it so that the units are converted. Arrange so that the units cancel out and leave the units that you are converting to. If it's on the top, you're going to multiply. If it's on the bottom, you're going to divide. I had said that back in the notes as we were going through scientific notation. So hopefully this is like rounding these things back into our conversation and you know, kind of giving you a full package here. So these are some informations from your textbook. You also have these in your formula pages. All the common conversions you should know. Not that you should have them memorized, but they should be provided to you. So these conversions are not something you need to have memorized. They are a resource. And if you ever short one of them for any reason, like a text question or a practice test, then feel free to ask. And yeah, that should be something that's given to you. So let's try some of these. And so what I've done is I've highlighted in my key, or when I do these, I highlight my unit conversion or my statement of truth that I'm going to arrange. So I'm going to start with what we know. So we know that we have 2.5 minutes, and units are everything in this. So we would like to multiply this by something that converts it to seconds and gets rid of minutes. So you might have thought of this ahead of time, like minutes and seconds. There is a fact that you know there are, in 1 minute, there are 60 seconds. And so that could be arranged either which way, but we're going to arrange it with the 60 on the top, because remember we wanted the where we're going to be on the top, and the 1 minute on the bottom. And this is the really cool thing about dimensional analysis, is that units are converted into what you want. And so like I'd said, if something's on the top, you multiply by. If it's something on the bottom, you divide by. So this would give me 2.5 times 60, or rounding to 2 sig figs would give me 150 seconds. This is an exact from counting, so there's no limitation on your sig figs with that question. All right, so moving across, we're going to go from pounds to kilograms. So you might want to look at the top and find a statement, a conversion factor that allows you to link those two units together. So 1 kilogram is 2.205 pounds, it says at the top. And I can arrange this so that it does the conversion. So I'm going to start with what I know and write it down with units. And then I'm going to write this so that the pounds are on the bottom, and where I'm going to, what I'm converting to, is on the top. So the numbers that go with kilogram is a 1. The number that goes with the pound is the 2.205. So this one, if I take a look, the pounds would cancel and it would convert to kilograms. If it's on the top, I multiply. If it's on the bottom, I divide. And then you can multiply by 1 and divide by 1, but I would see this as 3.0 divided by 2.205. And like I say, multiplying and dividing by 1 doesn't change anything, so that's why I've left that out. So that would give me my answer, rounded to 2 sig figs, to 1.4 kilograms. I can do a few more of these and then I will lay them out and put the answers up. The idea here is that you always start with what you know, and you can arrange your units before you have any information. So we know that kilograms would go on the bottom and pounds would go on the top. I would use that same conversion again. This time I put the 2.205 on the top because I'm just matching it to the units, right? I arrange the units and then the number goes with the unit from my conversion statement. So like that, and so I'd have 44 times 2.205, so that would give me 97 pounds. Useful tool. Sometimes people just know whether to multiply or divide, but dimensional analysis is something that gives you a strategy. So when you don't know what to do, you don't just know the answer, it gives you a strategy to problem solve and figure that out. I had the unfortunate situation of having to go for this one once, cooking, where my wholesaler switched to metric one year, and I had to do all the conversions on the fly. And yeah, you do get better at it if you do a repetitive number. But again, what I'm trying to show you with this stuff is a problem solving strategy. And so I'm just going to move through. You can fast forward if you'd like. I'm going to always find my conversion statement from the top. That's the resource that I know. I start with what I know. I can just arrange the units to cancel out what I had and convert into what I would like it to be. So I put the 1 on the top and the 2.54 on the bottom. I'd have 78 divided by 2.54, and my answer would have 3 sig figs, so 30.7 inches. If you like canceling these out, it is a good way to check that you didn't do something backwards. I sometimes make mistakes in doing things backwards, and so it does give you a chance to just double check your work. I also like writing out that conversion statement. Again, unless it's something that I'm doing repetitively, it keeps me from making mistakes, which I have illustrated to you, I think. Okay, so there's my statement going from kilometers to miles, starting with what I know, and then arranging it. And I can go so far as to put the units in even before I know the conversion statement, because I know that the kilometers are going to cancel and I'm converting to miles. And so I'd have the number of 0.6214 with the miles and the 1 down below. And so rounding this to 3 sig figs is 62.1 miles. The next ones I'll keep showing. Again, if you don't need them all the way through, you're welcome to fast forward. Oops, a little messy there. I start with what I know, always. I can arrange the units before I even get too far ahead of myself. And then I can use my calculator to do the math that it says. So this would be 3.57 divided by this number. If it's on the top, multiply. If it's on the bottom, divide. And of course, I'm ignoring the ones. I'm going to write this one in scientific notation. If you wrote it in standard notation, that's fine. There's no rules on that. But you want the value to be the same. The last two down here, sometimes these are just within the imperial system. I put them in your notes. We don't do this very much in chemistry, but your textbook is American, and so more of their examples actually are utilizing imperial conversions than is honestly practical in Canada or in chemistry. My point with this, though, is that it gives you this pattern for the conversions, for these unit conversions. And this is dimensional analysis. You're analyzing the units. You're analyzing the dimensions that are given. And the last one. And again, this one is considered, I don't have 2 sig figs. This is an exact number from counting, and so there's an infinite number of a certainty in that number, and so my answer would have 3 sig figs. So there's a few more examples. You can list these ones together. So sometimes it's not like one nice, neat conversion that you do. You can do multi-step problems. And so in these ones, you can do this dimensional analysis, this pattern of canceling out the units, but you can use more than one conversion factor. So I want to go from feet to meters. And so just taking a look at the information on the other side, I know that I could go from yards to feet. And again, that's just within the imperial system. And I also have a piece of information on the other side of the page that 1 meter equals 1.094 yards. It is quite possible for you to look up a conversion statement on the internet that goes directly from feet to meters, but I'm using these to illustrate this multi-step problem. So I found my conversion statements that I think are relevant for this. I'm going to start out with what I know. I'm going to convert from feet into yards, and then I'm going to convert from yards into meters, because that's where I would like to get to. That is the answer units. And so if I take a look, if I analyze my dimensions, if I analyze my units, all of these would cancel out. So in order to set it up, I focus on the units, but now I need to look at the numbers. And the numbers are just from my conversion statements here. I have 1 meter and 1.094 yards. In this one, if I multiply by what's on the top and divide by what's on the bottom, I'd have this 62.1 divided by 3 and divided by the 1.049. I would round my answer to 3 sig figs to get 18.9 meters. So there's another example here. This time going from kilograms to ounces, and like I say, maybe you can find on the internet a conversion statement that goes direct, but if we use the information on the other side of the page, I could go from kilograms to pounds and then pounds to ounces. And so I know that 1 kilogram equals 2.205 pounds. I don't just know that, I pulled it from the information on the other side of the page. And within the imperial system, we know that 1 pound is 16 ounces, and you might not have known that. But that fact is going to be what links us from kilograms to pounds, from pounds to ounces. So let's just map this out. I'm going to start with what I know. And I know that I'd like to get rid of the kilograms and go to pounds. And then I'd like to get rid of the pounds and go to ounces. And so this is illustrating this two-step dimensional analysis problem. This is step 1, this is step 2. And you can do it and then have it enter out here, or you can just go the distance and figure out your full answer all in one fell swoop with your calculator. So the numbers that go with the units, I'm just copying as I go. And these are all on the top, so I simply multiply through. I'm going to round to 4 sig figs because there's 4 sig figs in the original value. Again, this one's from counting, so there's an infinite number here, and there's, again, 4 here. And so in this one, my answer would be 177.0 ounces. And I would put that 0.0 in to preserve that 4th sig fig. So here's another example, bit of a word problem. So this one is about a diamond, and I don't know a ton about diamonds, and this really illustrates how useful dimensional analysis as a tool. So we know that there's a diamond that weighs this. This is what I'm starting with, and we want to go from pounds to carats. Carats are where we're going to end up. So I'm going to start with what I know. I've been given some unit conversions here that I'm going to arrange. I'd like to get rid of the pounds, and I could go to grams. And then I'd like to get rid of the grams and convert my units to carats. So the numbers that go with these, I've got 453.6 grams in 1 pound, and in 1 carat, it is 0.200 grams. And again, laying it out like this allows me to see all of these conversions. And I don't just know how to convert pounds to carats. I don't know that much about diamonds, when I might have been able to go from pounds to kilograms or something, just knowing when you multiply or when you divide. But in this case, this is something that is maybe outside your experience, and so you're really using this dimensional analysis as a problem-solving strategy. In this one, I've got 2 sig figs in my original number, and so I'm going to round my answer to 2 sig figs.